Bioclay could be really a game changer for the way we protect our crops in future. Crop losses caused by pests and pathogens are a big issue towards addressing the challenge of food security. Even with the current control measures available, we have 20 to 40% losses due to these pests and pathogens. Bioclay is a wonderful, innovative platform for crop protection. It is a combination of biology and clay, which is a clay nanotechnology that acts as a delivery vehicle. The driver for Bioclay is that we do need an innovative way to protect our crops from pests and pathogens. At present, the platforms that we have to protect those crops are either using toxic insecticides and pesticides or through genetic modification.
Prior research has shown that RNA can induce the RNAi mechanism in plants. So this is the immune system of the plant. If we can prime that immune system, then it can recognise an invading virus and destroy that virus.
So when the idea of Bioclay was being developed, for me the issue with using RNAi as a spray was that if you spray just naked RNA on a plant, it is not stable. It will just disintegrate within 3 to 5 days. So you have a very short window of protection that if the virus comes, you have sprayed on day 1, the virus comes on day 3, your plant is protected. But on day 5, your plant is not protected. With Bioclay, what we are doing is actually using RNA interference or gene silencing. We are delivering that gene silencing as a non-toxic spray application by partnering it with clay nanosheets or clay nanoparticles.
If you think of this clay as a lasagna, several sheets, we can put our RNA inside those sheets. When we spray the clay onto the plant, we have a degradation over time, so it degrades, and as it degrades, it releases the RNA.
And this is where the work done by Gordon Zhu and Max Lu comes in, that they provided me with this beautiful delivery vehicle, which is layered double hydroxide or the clay in this. And what this clay designed by them does is that when the RNA is loaded onto that clay, it is now protected from enzymes. It is now protected from degradation. It can now last on that leaf surface for about 30 to 40 days.
We combine the natural system. Say in the morning, sometimes there's some heavy dew, and also plant always breathes. So there's some carbon dioxide breathes out. Combine water and carbon dioxide. That's a slightly acidic environment. So that will decay and degrade clay particles, at the same time release the sRNA. So this is a control release.
I was actually giving a lecture on gene silencing or RNA interference, and Professor Max Lu, who was at that time at the University of Queensland, happened to be listening to that seminar, and we have a lunchtime discussion where I did highlight, there's a bottleneck. I wish we could, deliver RNAi as a spray. And that's where the genesis of the idea was when he mentioned to me, how about you go and talk to Professor Gordon Zhu at Australian Institute of Bioengineering and Nanotechnology at UQ, and maybe we can develop a platform together that can help in delivering RNA interference as a spray. Bioclay is a perfect example of multidisciplinary research at the University of Queensland. It brings in 2 institutions to deliver an innovative platform for crop protection that could be a game changer and address the issues of food security.